So in this example, we want to find the general solution of the differential equation dy dx equals 36 minus 12x squared over the square root of x cubed minus 9x plus 6. So the task is to find the general form of the function y equals some expression of x that satisfies this equation. So we want to find the function y whose derivative is this. In other words, this is just a whole different way to frame the question. We want the antiderivative of this expression. 36 minus 12x squared over the square root of x cubed minus 9x plus 6. Okay, so this is kind of a yucky looking integration problem when you first look at it. We want to try a substitution. So typically when we solve an integral problem using substitution, we prefer to let u be the inner function. So you look for where there's one function inside of another function. And so that's the case here. So we'd like to try letting u equal the expression under the radical, x cubed minus 9x plus 6. Let's see if we can make that work. So integration by substitution only works if we're able to, using that substitution, rewrite this entire integral as an integral in terms of u. So as soon as you set up your substitution, it's a good idea to find your differential du, which is going to be the derivative of this expression. So 3x squared minus 9 plus 0 times dx. So that entire derivative times dx. Now something that I'd like to point out here, so we could factor out a 3. So let's write this as du equals 3 times x squared minus, I almost wrote 9. Factor out 3. This is x squared minus 3 times dx. Alright, well, what we have outside of that expression of u doesn't really look like that. So let's think about this. If we want to rewrite this as an integral in terms of u, with the denominator we're in good shape. This is just going to be the square root of u. So I'm just going to write it in red. Think of it like I'm preparing to write this as an integral in terms of u, but I'm still trying to see how the pieces line up. So I'm just going to write it in red here and just label it. So that's about to equal u. So what's going on with this over here? I'm going to shift that over to the side. I think that helps to interpret this integral. If you take the numerator and just shift it over here, because we're hoping to use this remaining expression as a foundation to build this differential du. And so something we could note about this, well, what if we factor out 12? So this is equal to the integral of, so I'm going to use that color scheme again, x cubed minus 9x plus 6. And again, we know what's happening there. That's going to become u in a second. And then with this over here, say we factor out 12, or even, I'm looking at this and I'm looking at this. I'm trying to see if I can get things to match up. What if we factor out negative 12? If we factor out negative 12, that will leave positive x squared and negative 3. Better put brackets around this, times dx. So if you think to factor out the negative 12, just to make what's here look more like the differential du, then you start seeing how, okay, now I think I'm making progress. Thinking about the best way, how can we approach this? So we want to break away a 3x squared minus 3 times dx. So we could express that negative 12 as, I'll write one more line down here, even though I know I don't have a ton of room. Yeah, maybe that's a mistake. Hold on, let's go over here. So this is, all right, I've still got x cubed minus 9x plus 6. What I'm going to do now So I'm trying to build the differential du over here. What if I write this negative 12 as negative 4 times 3 times x squared minus 3 dx? And keep in mind, if you multiply all this out, you'll have negative 12x squared, positive 36. You'd be back with the original integral if you distributed the negative 4 and the 3. So we're still equal to what's in the original integral. But what you can do now, and I know this takes a little, sometimes integration is more an art than a science, so it takes a little bit of just kind of chipping away at the integral, and there are other ways to do this. But after a few adjustments, yeah, we could toss that negative 4 out front, and then what's left right here, 3 times x squared minus 3 dx, this is equal to du. This is equal to u, and we're ready to write this as an integral completely in terms of u. So the negative 4 is going to move out front. I think I'll write it in green. I've got too many markers in my hand here. Negative 4 comes out front. Integral of 1 over the square root of u times all of that is equal to du. So it took us a lot of sweat and tears. Is that how that saying goes? But it took us a lot of work. But we got this thing written completely in terms of u. So you have this much more complicated looking integral turned into a much simpler one. So now we want to find the antiderivative. So the negative 4 is just going to kind of sit there and wait. We can express this 1 over u square root of u as u to the negative 1/2 du. If you apply the power rule, add 1 to that exponent, that'll be u to the positive 1/2. And then we could put 1 over 1/2 in front, or I don't like to do 1 over a fraction. Let's just go ahead and put the reciprocal 2. Right? And you can always check this step. Take the derivative. 1/2 comes down, we'll have negative 4 times u to the negative 1/2 if you take the derivative. So this checks out. Plus c, now that we've taken the antiderivative. So notice the integration symbol goes away, and we tack on the plus c when we actually apply the power rule to find the antiderivative. Okay, and now it's just a matter of writing our final answer. So negative 4 times 2, that's negative 8, times u to the 1/2. So that's the square root of u plus c, where u is this. X cubed minus 9x plus 6. That's all under the radical there. This is the answer that you're looking for to that differential equation. And just one more thing I'll say before I end this video. You can check your work. Take the derivative of this, and you should get this after you do a little work with it.